In this part of the video, we will know about the multiplicative inverse, conjugate and modulus of a complex number. We will derive the common relation between these three. And then we will do some application questions from exercise 5.1 where we have to calculate or find the multiplicative inverse of a complex number. First, what is a standard form or general form of a complex number? General form of a complex number is z is equal to a plus ib. This is how we represent a complex number. Conjugate of this is z vinculum, which is a minus ib. So a plus ib and a minus ib are conjugate to each other or conjugate of each other. Then what is the meaning of modulus of the complex number? Which is root over of a square plus b square. So the complex number, its conjugate and its modulus. Now we will see how to find the multiplicative inverse. What is the meaning of multiplicative inverse? Multiplicative inverse is the reciprocal of the complex number. Can be written as z inverse, means 1 by z. Multiplicative inverse of a complex number is the reciprocal of the complex number. So we will write this as 1 by a plus ib. Then whenever we have imaginary number in the denominator, we will multiply to the numerator and denominator by the conjugate of the denominator. So we are multiplying a minus ib to the numerator and denominator, which is its conjugate. Multiplying the numerators, multiplying the denominators. So numerator is a minus ib and denominator is in form of a plus b times a minus b, which happens to be a square minus b square. Ultimately, z inverse means multiplicative inverse of the complex number is a minus ib divided by a square. There is a negative sign, I am writing negative, I square into b square. I square is a negative 1, b square is a b square. This in turn can be written as a minus ib by a square minus of minus plus b square. So z inverse is this, and what is a minus ib? It is conjugate of the complex number. And what is a square plus b square? Come to this zone. Z, modulus of z we write it as like this. Mod z is a root over of a square plus b square. If we square on both sides, we will get mod z square is a square plus b square. So a square plus b square is mod z square. So there is a common relation derived between multiplicative inverse, conjugate and modulus of the complex number, that is z inverse is z conjugate by modulus of z square. This expression we can use while doing the application questions to find multiplicative inverse of a complex number. This one, which is z inverse, is a minus ib by a square plus b square. So we can separate out the real part and the imaginary part. So this one can be written as a divided by a square plus b square, and then there is minus I times b by a square plus b square. So z inverse or multiplicative inverse of a complex number is a by a square plus b square minus I times b by a square plus b square. Now we will see some applications from exercise 5.1. Coming to applications of finding multiplicative inverse of complex numbers. Exercise 5.1, 11th question. We are given the complex number z is equal to 4 plus 3i. First we will compare this with the standard form. Standard form is a plus ib. So this can be written as 4 plus I times minus 3, and this is a plus ib. So a is 4 and b is negative 3. Now we have to find multiplicative inverse. First I will solve it or find the multiplicative inverse by regular process, that is multiplicative inverse of a complex number is its reciprocal. So 1 by z. 1 by z is represented as z inverse. So 1 by z means 1 by 4 minus 3i multiplied to the numerator and denominator by the conjugate of the denominator. Multiply the numerators and multiply the denominators. Denominators appear in form of a minus b times a plus b. So a square minus b square. So 4 plus 3i. 4 square is a 16, negative. 3 square is a 9. I square is a negative 1. Negative of negative is positive. So multiplicative inverse of z is 4 plus 3i divided by 16 plus 9. 16 plus 9 is 25. We should write this in standard form. So we'll separate the real parts and imaginary parts. So 4 plus 25 is the real part plus 3 by 25. This is a b, that is the imaginary part. So it is multiplied to I. So multiplicative inverse of z, which is 4 minus 3i, is 4 by 25 plus a 3 by 25i. So this is the regular process. Also, we'll find multiplicative inverse by using the formula that we have just now derived. Since multiplicative inverse is a conjugate of the complex number by mod z square. Conjugate of the complex number is 4 plus 3i. Mod z square. Mod z square, this is a square plus b square. A is a 4, b is a negative 3. So 4 square plus negative 3 square. So 4 plus 3i by 16 plus negative square is positive, 3 square is 9. So ultimately 4 plus 3i by 25. So using formula, multiplicative inverse is, we'll separate out the real part and complex part. That is 4 by 25 plus 3 by 25i. So using the regular process, the multiplicative inverse is 4 by 25 and plus 3i by 25, 3i by 25. So we can adopt one of the ways to find multiplicative inverse. The 12th question, where we are given the complex number, we are supposed to find its multiplicative inverse. So we'll find multiplicative inverse by using the regular formula. So first we will write the standard form. Z is equal to a plus ib, and we will pick up what is a and what is b. So a happens to be root 5 and b is 3. Multiplicative inverse of the complex number is represented as a z inverse, which is conjugate of z by mod z square. Conjugate of this is root 5 minus 3i. Mod z square is a square plus b square, where a is root 5 square and b is a 3 square. This turns out to be root 5 minus 3i divided by root 5 square is 5, 3 square is 9. So root 5 by 14 minus 3 by 14i. This is the multiplicative inverse of root 5 plus 3i. Going for the 13th question, we are given the complex number z, which is a negative I. First we should write this in standard form. Standard form is z is equal to 0 plus minus 1 of I, and the regular standard form is a plus ib. So a happens to be 0, b happens to be negative 1. A is a 0 and b is negative 1. So multiplicative inverse of minus I, z inverse, is conjugate of z by mod z square. Conjugate is 0 minus of minus I by root over of a square plus b square. So 0 square is 0 square minus 1 square. So this is I upon 1 which is I. So minus I is the same as minus I is the given complex numbers inverse, means I to the power minus 1 is a minus I. We have come to the last question of exercise 5.1. The question is, express the following expression in form of a plus ib. We are given one expression. So we have to write this complex number which is in complex form in the standard form. Standard form is a plus ib. Numerator is a product and denominator is a difference of complex number. Numerator appears in form of a plus b times a minus b. A plus b times a minus b is a square minus b square. So 3 square minus I root 5 square. Denominator root 3 plus root 2I. Minus is distributed over the bracket. So this is negative root 3 minus of minus plus I root 2. 3 square is a 9 minus I square is minus 1 and root 5 square is 5. Denominator root 3 and negative root 3 cancels. I root 2 plus I root 2 is 2I root 2 or 2 root 2I. 9 minus of minus plus 5 by 2 root 2I. So denominator is in this form. So we have to multiply to the numerator and denominator by the conjugate of I as well as the rationalizing factor of the irrational number that we see here. Numerator is 9 plus 5, which is 14 by 2 root 2I. 7 by root 2I. So we are multiplying to the numerator and denominator by root 2I. The numerator turns to be 7 root 2I. Denominator is root 2 into root 2 is a 2. I into I is I square. I square is a negative 1. 7 root 2 I by negative 2. Finally, the given complex number on simplification turns out to be negative 7 root 2 by 2I. Writing this in standard form, since its a real part doesn't exist, real part is 0 plus negative 7 root 2 by 2I. This is in form of a plus ib. So a is 0 and b is negative 7 root 2 by 2. So this is written in standard form.